Okay, so quickly, I'm going to make sure we kind of go through just my particular way of doing this type of problem. There is another way that involves finding an arc length and then finding that the line that begets the line segment that begets the arc length. I think this is probably a bit more simple and direct in terms of answering the problem. It also uses the law of sines and just an understanding of how to apply the law of sines. That's not always taught in a geometry class, but it is taught in classes directly related to geometry, i.e. trigonometry. So this does use trig functions. If this doesn't really work for you, that's fine, but let's just get into it. What the problem is telling us that we have a circle that has a radius of 6 and a triangle that's inscribed inside of that circle that is equilateral. Very convenient that it says that word equilateral because it gives us a lot of information. It gives us almost a ground floor or foundation of how we can actually solve the problem. And the main way we'll do this is starting with the law of sines. Basically, we're looking at the triangle here that I have labeled up a bit. The opposite, any angle inside of a triangle divided by the opposite side of that angle is equal to, in somewhat of a proportion-based form, the sine of one angle is equal divided by its opposite side is equal to another angle divided by the sine of another angle divided by its opposite side, which is also equal to the last angle divided by that opposite side. We know two of the sides and we know two of the angles. How do we know that? Well, we do know that has to be, we have one angle that's going to be 30 and another angle that's going to be 30 because it's an equilateral triangle. And therefore, if we just make a radius here and the radius here be two of the sides, using that outside part of that triangle being that third side, we know that this directly bisects or divides into two parts this particular 60-degree angle. So therefore, we have a 30-degree, 60 divided by 2, which is 30, and a 60 divided by 2, which is 30, for this new triangle that we're making here. We'll just call this a CAO or OAC, or however you want to talk about it right now. So we have a 30 and a 30, and remember, every triangle, no matter what, has 180 degrees. So we have this one will be 120. So if we go from using our information from the law of sines, we have this particular makeup for this triangle. And guess what? We're trying to find this side because this side gives us all three of the remaining as well. So making this a bit more simple, we just set it equal to one of the sine 30s divided by 6, and that'll be equal to sine 120 divided by AC. Using some quick cross multiplication and some calculation, we can go from sine 30 equaling sine 30 multiplied by the unknown line segment is equal to sine 120 times the value of 6. The sine of 30, using either your knowledge of the unit circle or frankly just using the calculator, if it's available to you, is 0.5 times its unknown times approximately 8.66. And I'm rounding roughly, but that's that, times 6. And therefore, when we divide both sides by that 0.5, we have AC, left with AC times pi is equal to 5.16 divided by 0.5 equals 10.392. Now, we're not done yet. This only gives us one side here. Remember that all of these sides are equilateral, which makes it really convenient to find the actual perimeter. So we just multiply that 10.392 times 3, and we get 31.177. Once again, this uses trig functions, but I think this is the most direct and clear way of giving an answer or getting to the final answer you need to get. You find the one side that you don't know, using the law of sines and using the information we have about an equilateral triangle, we can therefore produce this. Please let me know if you have any questions. I'm going to try to post a response that is also completely typed out so that if there's any issues with your audio, like I'm experiencing a bit today, we can get that done as well. All right. Have a good day.